Good afternoon to all. Today we will discuss message authentication code. Before starting this concept, let me revise the previous topic. So we started the third unit. So in third unit, how why there is a need of studying this topic is, see here, message authentication. So yes, used for protecting the integrity of a message, validating the identity of originator, source, and non-repudiation of origin. Okay, see here, ma. To provide this, for example, when Alice and Bob wants to communicate with each other, if an Alice and Bob wants to communicate with each other, okay, so if an Alice and Bob wants to communicate with each other, how a Bob knows that the message is from an Alice? So for that, the message is from an Alice, and there are two authentications that we are providing. Ma, try to concentrate. Just a minute. See here. So okay, there are two. What happened? There are two we need to concentrate. What are those two? Okay, so here is your Alice. Okay, here is your Alice. So in the entire third unit, we will be concentrating on two. What are those two? I will explain. Okay, here is an Alice, here is a Bob. When an Alice sends a message, when an Alice sends a message to Bob, what Bob has to know? 2 points. What are those? What Bob has to know? Bob has to know that the message is received from Alice, not from any other else. Okay, that is first point. Means authentication for user is one, and authentication to message is one. Means what? See here, see here, you are sending a message. For that message, is that message is modified by Eve? Is that message is modified by Eve? The Bob has to know. For that, there are three different techniques that are existing for providing message authentication. What are those three? One is message encryption, one and the other one is message authentication code, next is hash function. Okay, so see here, ma. To protect the integrity of message, means integrity of message is what? If an Alice wants sending some message to Bob, see here, so in the transmission, let us consider Eve is there. What Eve will do, Eve will try to modify the message or try to insert a new message. So when an Eve try to modify the message or try to insert a new message, how can a Bob how can a Bob be sure that message really comes from Alice? I said that it has to provide two. What are those two? Message received is from a authorized user Alice, and message integrity, meaning that the message what Alice has sent, the same message must be received by the Bob. Means, for example, Alice is saying that take care about one student. Okay, so let us consider Alice is sending that take care about one student. Okay, so what Bob has to receive, the Bob has to receive the same message that take care about the particular student. Okay, instead of that, don't take care about the student. Something if Bob is received means that indicates that there is some modification done by a third party, by a attacker called an Eve. Here is an Eve. Okay, so what we have to do for this, there are three techniques. Just now I said that the main concentration is a Bob Bob must know whether the message received is from an authorized user, Alice, and Bob must know that the message what Alice has sent was not modified in the transmission. In the transmission, for that, for message authentication, there will be three techniques. One is message encryption, message authentication code, hash function. Okay, message encryption, message authentication code, hash function. This we already discussed yesterday class, that message encryption will be of two types. One is symmetric and the other one is asymmetric. So in a symmetric, we studied about confidentiality using same key. So if this key knows between a sender and receiver, that indicates those are authorized persons. And how we are providing confidentiality in this is, we are providing confidentiality by converting our plain text to ciphertext. In the same way, we are providing an asymmetric also. Only we can provide only authentication, only confidentiality. If you want confidentiality, authentication, and integrity, digital signature, then you can combine all those, the above two services. This we discussed in the previous class. Now we need to start our message authentication code. Try to understand, this is very important topic, message authentication code. And before going for this message authentication code, it hash function and message authentication code will look similar, but there will be so much difference. What is that? I will explain after completing message authentication code. See here, a bit string, that is a function of both data and the secret key, and that is attached to the data in order to allow data authentication. Okay, this I will explain with the diagram. The function used to generate the message authentication code, the message authentication code must be one way. What is this one way? Till now we discussed about symmetric encryption. Asymmetric encryption means what? A sender will convert the plain text to ciphertext, and what the reverse is possible. So if a sender A is converting a plain text to ciphertext, okay, what the receiver is doing, let us consider receiver is B. Receiver is converting this ciphertext to plain text. So this is two way. Okay, given a plain text, sender is converting to ciphertext. Given a ciphertext, receiver is converting that ciphertext to plain text. This is two way. But message authentication code is a one way. Means what? Given a message, this is a message, let us consider this is a message that an Alice wants to send to Bob. This message will be converted to fixed size length. This message will be converted to fixed size length. Okay, and the receiver cannot convert this fixed size to a message. That is one way function. This is only used for identifying the integrity, and it is used for providing authentication. Only two you need to concentrate. What are those two? Those two. What? A Bob has to identify, once a message receives, whether the message is from an Alice is one point. The second point is whether the message is altered in the transmission is the other point. So for that, we are going for the message authentication code. So in message authentication code, we are using message authentication code. In this, it is one way. Means once a sender converting this message to fixed size length. Okay, this fixed size length cannot be converted. But if once a receiver receives this fixed size length, this fixed size length cannot be converted to the actual message. This is only used for identifying whether the message is modified and whether the message is from a proper user. That you can understand clearly when we go for explanation. But try to understand, one way is only you can convert the message to fixed size, but from fixed size length it cannot come back to a message. That is a message authentication code. So data associated with an authenticated message, allowing a receiver to verify the integrity of a message. Okay, so if we are attaching that message, fixed size message, what is the use of that is receiver will verify the integrity of the message. Receiver can identify that whether the received message is the one which the sender has sent the same or not. So for that we are having different techniques, but before that you try to understand the concept what I am explaining. Okay, so in other words, MAC is a short piece of information used to authenticate a message. Just now I said that authenticate a person, authenticate a message. So whether the message is altered or not. Okay, so see here also it is a authentication technique involves the use of secret key to generate small fixed size block of data. Try to understand, I already said that when a sender wants to send a message, this is your message. Okay, this is your message, And with the help of a secret key, it uses a secret key to generate a small fixed size block. Means let us consider these are 1000 bytes. Okay, this 1000 bytes will be converted to 1 byte. Let us suppose the type of algorithm that we are using in this. Again, we will be having different types of algorithms in this message authentication code. But if you apply a message for this message, where is this position? If you apply a message for this message, a key, so that this will be converted to 1 byte called fixed size. Okay, fixed size. Okay, then what is this fixed size actually? See here, I am applying 1000 bytes, so I am getting a fixed size of 1 byte. And if I apply 2000 bytes, will I get the other fixed size as 2 bytes? No. So whatever that you apply here will be converted to fixed size. Even there are so many bytes, like 2000 bytes you are applying, but finally it is converted to 1 byte only. Even if you are applying 4 bytes, we are finally it is converted to small fixed size called 1 byte only. Means it is here you are applying variable length. It will be variable length. Here is a fixed size. It will be variable length. Here is a fixed size. Concentrate my. So it is what? Using a key. So this is a key. So finally, this is a function. So message authentication code uses a function. The function is C, and inside that function we'll be having two. One is key. Try to concentrate, key. This key, you should get in the mind that what key is this? Is it symmetric type or is it asymmetric type? It is of symmetric type. Means a same key is used between a sender and the receiver. Means before communicating with each other, they will generate a secret key, and that secret key is used for generating a MAC code. Okay, for generating a MAC code, it uses C function. So a message, what the sender wants to send, this message is passed to MAC function. So MAC function is what? C is your MAC function. C of K, it is applied K to the message, so that the output from this is MAC. The output from this you will be getting as MAC. MAC is what? You will be generating a fixed size block of data. Okay, try to understand. Until here you must know about what we are doing. Simply let me explain once again. See here, in order to do message authentication, there will be having three techniques. In that we are studying about message authentication code. So let us see, this is your sender, Alice is sending a message. Okay, what this message has to be converted to fixed size, where we have fixed size. Yes, here fixed size block. For that, what we have to do is this message has to be given to C with K1. Means C is what? I already see. C takes, one is message, we are taking here from message, and the other one is K, which is symmetric. So yes, so the C is taking M, this MAC function is taking M, the plain text, and the key, and what it is generating, what will be the output from this, anyone? Okay, so where are we, ma? Okay, try to understand. When Alice wants to send a message, that message, this message, it goes to MAC function C. Okay, so in a C you will be having two. What are those two? One is message and the other one is symmetric key. Okay, it even has to take key, so that the output from this is fixed size. The output from this is fixed size block of data. The output from this is fixed size block of data. So the output from this is a MAC, which is fixed size. Means whatever the message length is, but finally the output will be a fixed size message. Okay, so this message will be received by the receiver. Okay, will be received by the receiver. What receiver will do? Yes, Receiver, whatever the Alice has done, considering a message, doing a Mac function, the same receiver will also do. Okay, means, but before that, what receiver receives is very important. What receiver receives is what Alice will do. Alice will concatenate, means append. Alice will append what the message is, the message, the message, and the calculated Mac. Okay. So the message that an Alice wants to send to Bob is, "Hi, hello, how are you?" So this is the message, "Hi, hello, how are you?" For "Hi, hello, how are you?" this is your fixed size length called Mac. This will be sent to the receiver called a Bob. Okay, try to understand. But how, main question is how Bob identifies that the message is from an Alice, and how Bob identifies that the message is not a modified in the communication. First question is, if a what Bob will do, Bob will take this message. Try to understand. Bob will take this message, and what Bob will do, the same process what the Alice has done, the same process will be done by Bob. Means what? Again, Bob will take this message. After taking this message, Bob will do what? Bob will send this to Mac function called C, and it applies K. It applies K. Which K? The K which is used by Alice. Means already I said that this is symmetric. Symmetric means the same key is used between a Alice and a Bob, between a two parties. So once if it uses this, you will be generating what from this Mac. Okay. Now, how can a receiver knows that the message received is not modified? It is same based on what? The Bob has calculated a Mac. This Mac and the Alice what the Bob Mac has created, both will be compared. If both are same, then there is no modification. The message exactly the what sender has sent, the same message as received by Bob. If there is no comparison, if the Bob compares what the Alice has sent the Mac and what Bob calculated the Mac, if both are same, it will accept that message. If both are not same, it will ignore that. It will ignore that. Why? Because the message has been tampered, the message has been altered in by the Eve. Okay, so understood. So how now? First is Bob identifies that is altered. That means among two, one is completed. Second one is completed. What? The message has been modified so that the Mac which is generated from the receiver and the Mac which is generated by Alice is not matching. Next one is how a Bob identifies that the message is from an Alice. Why? Because if a Bob can use this K, that indicates that they are using a K. Only knows this K, the key K is only known by an Alice and a Bob. That means they are an authorized person. So authentication is proving and message integrity it is proving. Message integrity is it is proving. Let me show with an example so that you can understand even more clearly. Okay. So see here, message authentication code. So message authentication code generated by an algorithm that creates a small fixed size block. This small fixed size block will be fixed to whatever the input that you are giving. Okay, depending on both message. So how you are generating this fixed size block means it depending on both message and some key, and this key is symmetric. Keep it in your mind. Okay, like encryption. It is not reversible. I already said that in an encryption, and sender can convert a plain text to ciphertext, and receiver can convert ciphertext to plain text. But this will not be happening in a Mac. Once converted, this same process has to be done by the receiver, so that receiver will identify appending to message. So appended to message as signature, appended as signature. So what? So along with a message we are adding what? We are adding the one called fixed size block. Operations. This technique assumes two communication parties, say A and B, share a common secret key. Share a common secret key. Just now I said that C, Mac function uses k and message for generating a fixed so m is what input message, which is variable length, okay, which is variable length. C is what? C is your Mac function. K is what? Shared secret key. Mac is what? Mac will be generated, which is fixed length message authentication code. Okay, the message plus Mac are transmitted to the intended recipient. The message and what Alice will do, Alice will along with a message, Alice will add a Mac. Okay, will add and will send to the recipient. What recipient will do? Can anyone? What Bob will do? What Bob will do? This is your Mac, the message, input message, which is variable length, and C is a Mac function, K is a shared secret key, Mac is message authentication code. So what the message plus Mac are transmitted to the intended recipient. The recipient performs the same calculation on the received message using the same secret key to generate new Mac. The received Mac is compared to calculated Mac. Operations methods assume that only the receiver and the sender know the identity of the secret key. The received MAC matches the calculated MAC. Therefore, the receiver is assured that the message has not been altered, and the receiver knows that the message is from a true sender, and there is a sequence. This operation, the sender and the receiver, before calculating a MAC, they must know the secret key K. They must know the secret key K. So assume that the receiver and sender know the identity of the secret key. Okay. So next is what the received MAC matches the calculated MAC. What is this received MAC matches the calculated MAC? The sender will calculate a MAC, and that MAC along with a message will be sent to the receiver. What receiver will do? Receiver, what the sender has done, the same process the receiver will be doing. So that receiver will also calculate the MAC, and the MAC which is sent by the receiver and the MAC which is calculated by the Bob, both will be calculated. If both are same, then there is no alteration, then the message is from a proper user. This main concept. See here, I will show this with an example. At last I will ask you the question, definitely. So if I want at least from 2 students a response, anyhow I cannot upload this video also. This is your message, this is your message. So this message, let us consider these two. This is your Alice and Bob, this is your Alice and a Bob. Okay, wants to communicate with each other. For communicating with each other, what is the first process? Assume they know they have a secret key K. Okay, secret key K, let us consider the secret key that Alice and Bob using is 4 for sake of understanding. Now what Alice is doing, Alice, the message what it wants to transfer to Bob, it is not sending the message actually, it is converting that to MAC function, which is C. MAC function, which is C. So this function takes 2 inputs. What are those 2 inputs? One is the message and the other one is what? K, which is key. This key is used, must know, Alice must know this key and Bob must also know this key. Okay, so this message, this is the C. Okay, so in the C, it is taking input as a message and the key K, so that it is generating a fixed size block, which is MAC. Okay, so this message is variable, it is the size is not fixed. In this, the MAC generated is fixed size. Okay, next, after generating, what Alice is doing is, what the message that the Alice wants to send, this it is keeping as it is the message. Okay, and after calculating with the help of this key and the message, we are generating a fixed size. That fixed size what Alice has generated, it is fixing this and it is sending. So this both, it is sending to what? Bob. What Bob is doing? Bob, what the process that Alice has done, this process, the same process the Bob is doing. Why? Because this message has transferred in the interconnections, as it is, in order to convert this in order to transfer this message to Bob, it has traveled through so many intermediate routers, like so much transfer, it will be passed, right? So in this, in the middle, he may transfer that data, he may modify the data, or he may delete the data, or he may alter the data, modify the data, or insert the data. So at last, Bob will do, what Alice has done, the same thing Bob will also do. What? Taking a message from this, we'll be having two partition, one is message and the other one is Mac. Okay, so what Bob will do, Bob will take the message from that, the same process. What Bob will do, Bob will, for this message, it uses a Mac function, and it applies a key so that it generates a fixed size block. This which is generated by Bob, this is which is generated by Alice. If both are same, okay, we are providing authenticity and integrity. Means the message is from a proper authorized person. And next is, if it is same, then it is providing integrity also. No means it will not accept. No means it will not accept. So it will give a request to Alice to resend it again. Okay, so that is a concept of Mac. Okay, so see here, just now I said that Mac is, it uses a function C, K comma M, where M is an input message, C is a Mac function, K is a shared key, and M is a message authentication. Mac is a message authentication code. Okay, so can anyone tell me what is the problem in this? Which service it provides? Which service it provides?
Authentication.
Yes, so it only provides authentication. Why? Because Alice is not converting a plain text to ciphertext. Alice is sending the same plain text to the Bob. So the middle Eve can see this message and can read this. Why? Because it is not converted that plain text to ciphertext. It is only concentrating to authenticity and integrity of a message. But the problem here is, we are not encrypting the message. Whatever hi, hello, how are you is there, the same hi, hello, how are you, it is reaching to Bob, and others also can read. Why? Because it is a plain text. It only provides a service called authentication, and it also provides integrity. Okay, so to show that, to provide confidentiality, what we have to do is, to provide confidentiality, what we have to do is, think about this. Can anyone, what we can do for providing authenticate, for providing confidentiality? This message this message can be encrypted, right? This message can be encrypted. So see here, I will show you. This is a simple one. This is a simple one, what we discussed till now. The message is there. We are applying Mac function by giving key and a message, so that we are getting what? So that we are getting what? We are appending with the actual message. So we are getting, one side will be having a message, and the other side will be having what? A Mac function. And what receiver will do? Receiver will do the same process that the sender has done. We will take this message, will calculate a Mac function, and this will be compared. But the problem here is, the message that it is passing by sender and the receiver is plain text. Attacker can read it easily. So we are going for what? We are going for providing confidentiality also. So for providing confidentiality, what we are doing here, see here, concentrate. The same process till now, what we discussed is, what we have considered a message. We have taken that message, and we passed this to message authentication code, so that we are generating Mac. This Mac and the message we are concatenating. So this side, what we will be getting, we'll be getting one side of the message, which is plain text, and the other side, which is Mac. This entire, what we are doing, we are encrypting with, again, one more symmetric key, K2. Again, one more symmetric key, K2. So K1 is used for generating a Mac. This K2 is used for encryption of your message. So it is encrypted, and it is sent to the receiver. What receiver will do? This is the message. So what is the message? First what we have done, see what we have done here. See, already I said that, see, K1 comma M. Okay, so this, along with this, here is what we appended message also, plain text message. So this plain text message, this entire we are encrypting with k2 comma, you will be getting all this, and this you are encrypting with k2. So this is a expression. Okay, so now this has to be decrypted, as the first key is k2, so you have to use k2 first. Okay, so you have to decrypt. After decrypting, what receiver will get? Receiver will get a plain text, and receiver will get a mac. Receiver will get a plain text, and receiver will get a mac. But after receiving, what receiver has to do? Receiver has to take this plain text and has to convert that to this mac, and receiver will generate, or receiver will also calculate mac. Okay, this mac and whatever which is there in this mac, which is created by a source, both will be compared. If both are same, then the message is not altered in the intermediates, so it will be accepted. Okay, so for the next class I will discuss the remaining. Just a minute. I will ask you the questions, ma, definitely now. Is audio is you can hear the audio? What, ma? Are you able to see the video that I am showing?
Audio is not audible.
Uh,
Audio is
audio
not
any
audible, ma'am.
audio anyhow, it is not explaining anything. Just see the concept.